This is Geometry Unit 12, Lesson 7 on lengths of chords, secants, and tangents. What we're going to look at in this lesson is actually finding the measures of the segments that can be drawn in a circle. So we can find the lengths of chords, find the lengths of secants, and find the lengths of tangents, rather than angle measures. So let's look at intersecting chords. Segments formed by intersecting chords. Remember, chords are segments that are drawn whose endpoints are on the circle. So AB and CD are two chords that intersect at point E. The theorem about finding the length of chords is when two chords intersect inside a circle, like this, the product of the measures of the segments of one chord is equal to the product of the measures of the segment of the other chord. Basically, the pieces the chords are split into, you multiply them together and they're equal to each other. Basically, they're in proportion. So that means if these two chords, A, B, and C, D, intersect to E, the product of AB segments, which would be AE times EB, will equal the product of the other two segments, DE times EC, the product of the pieces of each segment. So that is the theorem for segments formed by intersecting chords. So if we want to apply this theorem, these are two chords right here. The intersecting chords, you have 8 and 12. So 8 times 12 are the two segments that make up this chord, will equal the product of the two segments x and 6, x times 6. 8 times 12 is 96, 6 times x is 6x, and then 96 equals 6x divided by 6, and x is equal to 16. So there we go. This value of x is 16. Okay, now let's see if we can do a little challenge here. In the diagram, which is not drawn to scale, AE is 12, EB is 6, CD here is 22. Find the lengths of CE and ED if CE is greater than ED. Okay, so these are two chords intersecting, so we know the product of the chords are equal, the segments of the chords. So that means that AE times EB should equal CE times ED. Problem is, we don't know what CE and ED are. Well, we do know that CE and ED are 22. So that means one of them is going to be x. Let's make CE x. And let's make ED 22 minus x. Because whatever's left over when we take away x will be left from 22. So there we go. So now we've got our values. AE is 12. EB is 6. CE is x. And ED is 22 minus x. All right, so just multiply. 12 times 6 is 72. Distribute here, we have 22x minus x squared. Okay, this is a quadratic, so I want it to get equal to 0. So I want this to be positive x squared so I can factor it, so I'm going to actually move these two to the other side. So this becomes x squared minus 22x plus 72 is equal to 0. All right, factor, factor, factor. This is going to be x and x. And since it's plus here and minus here, it's going to be minus, minus. The factors of 72 that add up to negative 22 would be 18 and 4. All right, set them equal to 0. And x is equal to 18, and x is equal to 4. Okay, so we got two values of x, which is perfectly fine. All right, so x could either be 18 or 4, but remember this said that CE has got to be greater than ED. So would x be 18 or would x be 4? Well, since CE is greater than ED, so that means CE will be 18. And that means that ED will be 22 minus 18, which is 4. Okay, so since this one is the larger one, this one would be 18, and this one would be 4. Okay, so when segments intersect, the product of chords, the product of the segments are equal. That is for chords. All right, our next kind of segments are secants. Let's look at segments formed by intersecting secants. Remember, a secant is drawn from an external point and it hits the circle in two places. So PA, from here to here, is a secant. And PC is also a secant because it goes all the way to there. That's the whole secant. Now, secants also have an external part. This part right here and this part right here are the external part of the secant because it's outside the circle. All right, so knowing those values, there is a theorem that works for secants. When two secants intersect outside a circle, the product of the whole secant and its external segment is equal to the product of the other whole secant and its external segment. So it's whole secant, which would be PA, times its external part, which would be, in this one, PB, will equal the whole secant here, which would be PC, times its external part, which is PD. Whole is to part as whole is to part. That is the formula for secants. So let's try out this theorem. All right, the whole secant for this one would be 18. Its external part is going to be 12. Okay, now for the other one, what would be the length of the whole secant there? It would be x plus 8. Not 8x, it would be x plus 8. Times its external part, which would be 8. Whole times part equals whole times part. All right, so multiplying this out, we get 12 times 18 is 216. Distribute the 8 through the x plus 8, so it's 8x plus 64. Subtract the 64, you get 8x is equal to 152. And if you divide by 8, x is equal to 19. All right, so x here is 19. And the whole secant, if you want to work it out, is 27. So there we go. Whole is to part as whole is to part. Okay, the last one is the segments formed by a tangent and a secant. Remember, a tangent only touches the circle in one place, while the secant does it in both places. All right, now this is really basically the same one as the secant, but the difference is the external part of the tangent is the same value. So when a tangent and a secant intersect outside a circle, the square of the tangent segment is equal to the product of the whole secant and its external segment. Okay, well, if you think about this, this makes sense. The whole tangent would be PA, and its external part would also be PA, wouldn't it? So that means that's going to be PA squared is equal to the whole secant, which would be here. This is the tangent, which would be PC, times its external part, which would be PM. All right, so this is the weird formula, but it does work. In the diagram, which we have here, okay, PA is a tangent segment. PA is 4 times the square root of 6. And MC is 4 more than PM. So PM is x, and MC is 4 more than that, so that will be x plus 4. Okay, so the formula is the tangent squared, which would be PA squared, is equal to the secant, PC, times its external part. All right, so PA is 4 radical 6 squared is equal to PC. Now PC, remember, is the whole secant. So what would be the length of the whole secant? It would be x plus 4, so that would be 2x plus 4, times PM. The external part of the segment would be x, right there. Okay, now be very careful. 4 square root of 6 times 4 square root of 6 is 16 times 6, which is 96. And then this distributes, 2x squared plus 4x. Okay, quadratic equation again, we want it equal to 0. Subtract the 96. We get 2x squared plus 4x minus 96 is equal to 0. Okay, now these are all divisible by 2, so that gives me x squared plus 2x minus 48 is equal to 0. Okay, factor, factor, factor. This is going to be x and x. And then we have positive 8 and minus 6 to get it equal to 2. 8 minus 6 is 2 to get the middle. Set them equal to 0. And x is equal to negative 8, and x is equal to 6. All right, now since this is the length of a segment, we can't have any negatives. We have to reject this. All right, now if we're looking for the length of PC, PC, remember we said was 2x plus 4. So this is going to be 2 times 6 plus 4. 2 times 6 is 12 plus 4 is 16. So there we go. This is the length of PC. So we now have 3 theorems. We have intersecting chords, 2 secants, and a tangent and a secant to find the length of those values. All right, so you have to know how to do those formulas when you do these problems.